Howdy, this is my Biofuel project on microalgae. Algae is considered one of the most sustainable and efficient sources for biofuel since it grows rapidly, can be cultivated in any type of water, and does not compete with any other food crops. Below I provided the description of the different types of generations for biofuels, and microalgae is considered to be the third generation. Algae grows via photosynthesis, using sunlight to convert carbon dioxide and water into sugars and oxygen. The sugars are then turned into lipids, which is the primary source for biofuel. The two main ways algae is grown is open raceway ponds, which are large, shallow ponds with paddle wheels that circulates water. The second being photobioreactors, PBRs, which are closed systems that provide controlled light, nutrients, and CO2 levels for optimized growth. The production process for microalgae biofuel starts with photosynthesis, where algae absorb sunlight to produce organic matter, which is then separated from water using centrifugation, filtration, or flocculation. The third step is where oils are extracted using solvents like hexane or through mechanical methods. The fourth and final step includes the conversion, the first being transesterification, which turns extracted lipids into the biodiesel. Fermentation is where if sugars are targeted, then it turns it into ethanol. And the third being anaerobic digestion, where it produces biogas from algal biomass. Development status for microalgae biofuel. Algae biofuels are currently in advanced research and early deployment phase. Although pilot and demonstration scale projects are ongoing, large-scale commercialization is limited due to high production costs as well as technical challenges. However, recent advances in genome editing, strain engineering, and photobioreactor design are making large-scale biofuel production more feasible. Carbon footprint for microalgae. It is considered low carbon or carbon neutral due to algae offsetting emissions from fuel combustion when it absorbs this carbon dioxide. Cultivation can then use waste CO2 from power plants or industries to convert emissions into fuel feedstock. When powered by renewable energy, the entire biofuel production process can turn net negative. The economic impact. The economic impact is currently limited by high operational costs, which include cultivation systems, harvesting, and lipid extraction. However, the economics improve when leftover biomass is used for animal feed, fertilizer, and even cosmetics, or when algae is used as a way to purify wastewater. Communication with the public. Awareness of algae biofuel is still limited outside scientific and industrial circles. Types of communication includes demonstration projects, educational campaigns, and media coverage. Current analysis and my recommendation. Algae biofuels are considered environmentally valuable but not yet economically competitive without subsidized. Recommendations I have: encourage the government for more field projects, expand education and outreach to gain public support, and continue funding research into low energy methods. Plan with unlimited funding. Develop different cultivation methods in multiple climate zones. Design biorefineries to convert algae into fuel. And lastly, use said fuel for transportation systems.